This PetroSkills PetroAcademy skill module covers leakage and dispersion, combustion behavior, and sources of ignition at the fundamental competency level. This section introduces the module. Why do we need to spend time on leakage and dispersion, combustion behavior, and sources of ignition? The Leakage and Dispersion of Hydrocarbons core module provided a discussion of the principles involved. If we are going to effectively apply the principles of process safety, we need to understand what is likely to happen after we lose containment. This includes the factors which govern leakage and dispersion, the combustion behavior of common hydrocarbons, including the effects of fire and explosion, and sources of ignition. This directly affects facilities design, operations, engineering, and maintenance. The Marsh Incident Database, published every year, consistently shows fire and explosion as the leading cause of loss in most of the major incidents. We normally design for one major incident at a time, contained within the process unit in which the incident originates. If we fail to contain the incident, it will escalate into a major incident, which is unlikely to be readily controllable. Without a good understanding of process safety, errors can easily be made in design and in subsequent modification of facilities. Our understanding of process safety also affects how we operate and maintain our facilities and how we respond to emergencies. For example, do we understand what governs selection of separation distances, the effects of thermal radiation and of overpressure, and how to estimate leakage and dispersion? Do we have a useful understanding of sources of ignition, including some of the less common sources? How can we identify deficiencies, particularly in older systems that may or may not meet current standards? Facilities engineers and project management personnel often have broad responsibility for technical decisions that affect the long-term process safety of hydrocarbon facilities. While many companies have specialist support available, those resources are usually available on specific request rather than for routine work. Without a basic understanding of the subject, we may not know when to call in a specialist. This module is at the fundamental level, building on the material covered in the core modules. There are some quantitative calculations to work through as you learn the concepts. Although very good software tools are available, relatively simple calculations can often be useful, particularly in the early stages of a project before we have sufficient data to support a good model, and also in existing facilities as a screening tool to guide us as to where detailed models are needed. It is a useful development step from which you can progress as you need increased competency in the subject. The 3 lecture sections in this module are leakage and dispersion, combustion behavior of hydrocarbons, and sources of ignition. In the leakage and dispersion section, we will discuss leakage rates, conditions, and state, size of the vapor cloud, dispersion calculations, downwind concentrations of contaminants, probit functions, and modeling software. In the combustion behavior section, we will discuss fire triangle, thermal radiation, fires, and explosions. In the sources of ignition section, we will discuss electrical area classification, lightning protection, and flame arresters. There will also be 2 live virtual sessions that give you the opportunity to share lessons learned from the application of what you have learned in the example facility and ask questions about the module so far. This module will cover the following learning objectives: estimate leakage rates, determine leakage conditions and estimate changes of state, estimate the size of the vapor cloud, estimate downwind concentrations of contaminants, summarize the use of the fire triangle, estimate radiation based on a point source model, estimate thermal radiation damage from tables and from a probit model, estimate dimensions for common types of hydrocarbon fires, explain what circumstances would justify advanced methods of calculating overpressure and uses for the results. Explain uses and principles of electrical area classification, List lightning protection alternatives, using protection of a fixed roof tank farm as an example. Explain how flame arresters work, and identify the strengths and limitations of flame arresters. In this module, we will work on exercises based on an example facility. Shown here is a block diagram of the example facility. A downloadable PDF version of this block diagram is available in the Additional Resources section. Details about the facility are provided in the PDF.